do it.
Rooz from Gradle here.
Emmanuel from Netflix.
And today we're sharing the developer productivity journey and me working with Emmanuel and for the whole Gradle team working with the Netflix Android team for the last few years and share some of our wins and findings with you all. Before we jump in, just want to say how we met, right? I'm one of the organizers of the San Francisco Android GDG. We were in a basement at Airbnb with the Android team there. Michael Dang and those folks helped organize that. And that's how I met Emmanuel. He came to me and was like, hey, let's talk about builds. And that's how it all started. And that's the power of community. And thanks to the DroidCon folks for really going out of their way to organizing this event during the pandemic. You don't know what's going to happen, right? And that's the beauty of community. If we didn't go to those meetups, if we didn't come to these conferences, we wouldn't have met, and this talk wouldn't be happening today. All right, so here's what we're talking about. We're talking about how Netflix does builds. We're going to go through modularization and some of the wins that they had there. Then we're going to jump into the productivity journey, some of the tools that we use, build performance regressions, and wrap up with some dependency management and best practices, if we have time. We'll see. It's a lot of stuff here. We're going to try to get you through it, so bear with us. All right, so Emmanuel, how does Netflix do builds? Tell us a little bit about the build environment.
Okay, so at Netflix, we have a team of about 30 developers working on the Android code base. We use a pretty standard toolchain like Android Studio. AGP, we use the latest 7.2 and Kotlin the latest 1.621. We try to ship APK every week to the Play Store. And our project is a Gradle project. We have 180 modules at that time. We use 10 variants. We have 2 variants we ship to customers like Amazon and Google Play Store.
Nice, so you got 180 modules. You got 30 developers. So this whole this is not the UI team. This is like the whole app is 30 developers.
This is a UI and a platform. And yeah.
Pretty impressive. So they have a lot of work to do, these folks, to ship every single week for an app that's used by millions of people. Tell us about the CI/CD pipeline. What do you use there?
So in terms of CI, we run a Git with a Bitbucket server, and our CI is running on Jenkins. Our continuous delivery platform is a Spinnaker, and every change we make to our source code go through a pull request with a manual review. And on top of that, we are running a lot of automatic review. So we run static analysis like get-lint, detect, lint, and we have a lot of custom lint rules. And on top of that, we are going to run all our unit tests and all our UI automation tests, which are running on a device lab, and so on real device or on emulator.
Nice, and you're using Espresso for that.
And we're using Espresso for UI automation testing. We're using JUnit, JVM, and RoboElectric for unit testing.
Got it. So RoboElectric and Espresso. Great. And so for you to pull this off, I remember one of the initial things that you guys had to do was improve the incrementality of the build. Tell us a little bit about what you did there.
Yes, so exactly like when I joined Netflix a few years ago, I look at the build speed, and the first time you want to look when you want to work on performance is just check out your repository, and from a clean directory, just run an assemble debug and see how long it takes. And this is going to be your clean build. Okay, so in that case, we see we have like 7 minutes, 3,500 tasks executed. And the thing you want to do next is in the same directory, just run assemble debug again. And what you expect is a very fast iteration.
So no changes, it should be 11 seconds, right? Yeah. No code change, this thing should run.
It should be your configure time, and everything should be up to date, okay?
But that wasn't the case.
Yeah, that wasn't the case. So when we did that first, we realized that we still have these 500 tasks that are still executed. So, you troubleshoot, and as them, we probably use the build scan to see what tasks were going to be executed at this one time. And then we realize with some investigation, so you check your build Gradles and your scripts, and then in that case, it's an example where we inject a build date into a build config field. And for one of the features, we need this. But we don't need this for maybe for a fast incremental build. So what this thing is doing is going to generate your build config class, and it's going to add these new attributes from Gradle. And you see there is a timestamp in this attribute. So every time you build, the value is different. So the input is different. We need to recompile this class and all the classes that are dependent of this class. So this was generating 500 tasks.
And in my world, we see this all the time, right? The build cache, your incremental build cache getting invalidated because there's a timestamp or something in there that's slowing stuff down. And you got 30 developers running over 1,000 assembled debugs builds a week.
Exactly.
Right? And if these things take 2 minutes, we're talking about a lot of engineering minutes there. So what did you do to get around this problem?
So the thing is, because this field is not really necessary when you do your incremental work, what we introduce is an engineering build, okay? And we have this fast build that we are going to skip all this dynamic value we could get in this QCS. For the build date, we are going to put a static value. And this is going to increase the build time we won't have this 500 task re-executed. So what we introduced quickly in our build is an engineering build where we do all this optimization and incremental compilation. We remove a lot of unnecessary plugins. For example, we use the Jacoco, which is a code coverage, and this plugin is taking a lot of time at configuration time. So we don't need that when we work on our studio. We remove some obfuscation plugin, we remove some variants also, because the more variants you have, the more configure time is going to be slow. And we also use an app bundle in our app. So app bundle is this new deliverable you can deliver on demand to your customer from Play Store. And we remove all the app bundle from the build. It makes the build faster. 95% of the time, we don't work on app bundle.
So you essentially created a eng build to decrease some of the noise so developers could get faster feedback from the toolchain.
Exactly.
So what was the result?
So here, the result, so if we take our dashboard of Gradle Enterprise, we can see that our engineering build now is about 2 minutes, okay? And if I take the same build, I'm going to run from CI, which is not engineering build, so not optimized, it's going to take about 7 minutes.
So the average, and that's the interesting part here, right? The average is 2 minutes. Some of the best cases are running in seconds. And this enables developers to get this faster feedback before they send and ship their code to production, where other variables and stuff can go wrong, right? And there you see 939 of these builds have been ran. So 2 minutes versus 7 minutes, lots of productivity gains there.
Yeah. And so the second part of this effort was modularizing our app. As a lot of apps, we add big monolithic application modules, and every time you make a change, we need to recompile all the source code from this app module. So we started, so the approach we took at the beginning was, let's take this application module and move it as a library module and extract some of the code to some other libraries, you know. This one not super easy. It required us a lot of abstraction, but it was a first step, and at least if you update your UI feature, which will be in this big library, you just recompile this big library and the application shell, so we don't have to recompile all the other libraries. But that was not perfect, and where we are now is we use this notion of feature modules, where we have a public API. So one module is composed of 2 or more Gradle modules, and we have a public API, and we have a hidden implementation. So the application is dependent of the hidden implementation because it knows what to instantiate, but all the other modules just have a dependency on the public API. And most of the time, you are going to work on your hidden implementation. So this looks like that. And the advantage is, since most of the time we work on the hidden implementation, when we make a change in an implementation module, we just need to recompile the implementation module and the application. So it makes us a very fast iterative build. Of course, if you modify a public API, you always need to add methods or data classes. Then you will trigger a lot of recompilation, but it's by design. So modularization was a second effort for us to really improve fast incremental build time. So we use dependency injection, and all this features module is powered by a Dagger hilt as of now. And so even if it makes a better build time, it's also a better architecture for your code because it makes your code more modular, and it makes also your code more testable, you can easily switch implementation.
And the key takeaway here, it's not just about build performance, right? And that's what a lot of folks think about modularization, but it helps with the whole architecture of the build. And how long did this effort take for you guys?
It took
because you were there when it was a single module. I recall we had that conversation. It was just one single module monolith.
I would say going from a monolithic app to this new features module took about a couple of years. But what we did is we also invested into tooling. Because every time you want to create a new feature, we don't want all the developers to know how to create a new module or two modules. So we have some custom tasks in our Gradle, which are going to be interactive and ask you some question like the name. And this is going to generate for you the Gradle module and going to integrate the Gradle module to the build. And we generate all the dagger hilt binding in this, so there is a lot of code generation. So developer can just focus on the feature. So yes, so as a best practice at Netflix, what we do is we have this dev build mode, which is optimized and it's enabled by default. Only CI opt out, and the build is really lighter, no app bundle, less plugin. And we use this modularization based on hidden implementation and public API. So, you do a lot of optimization and you work hard to make your build faster, but how do you make sure that you don't regress? Because it's easy with Gradle or with Android project, you add a dependency, a notation processor, and your build time is going to be impacted. So what we do use now is we use Gradle Profiler, and this is a link to the Gradle Profiler if you want to scan it. It's a really useful tool from Gradle, and it allows you to define some scenario. And it's some real-time scenarios that developer will do. So basically you say, okay, I want you to modify this file and give me the incremental time for this scenario. So we run like maybe 4 scenarios, and we have 2 modes to run it. We run on demand. So let's say you update HGP, you add a new addition processor, you're worried about impacting performance in build time, you run it on your branch versus the main branch. And we also run it on a daily basis, or maybe more than daily basis, because we want to spot regression as quick as possible.
And pro tip, right? If your app has a lot of modules, you're going to have configuration time challenges, and this tool is really helpful for diving really deep into that. Another tool that's super helpful, one of my favorite tools, is a build scan. Anybody in the audience created a build scan before? Okay, we have some folks here. It's a 50-50, so great. So you'll learn something new today. So and when we first met, we were talking about build issues. I'm like, hey, send me a build scan. And we saw some really interesting stuff there. And you could go to scans.gradle.com. It's a service that Gradle provides. You could run your build with the -scan, and you get a nice URL that takes you to this UI of everything that's happening in your build. So especially when it comes to performance, it's really interesting. Other low-hanging fruit is the build cache, right? And build scans and build cache really come together, right, to try to figure out what is slowing down my build, right? And for folks who are not familiar with a build cache, right, it's different from a dependency, binary repository, artifact cache, right? We're caching all the steps in your build process, right? We're talking about the tasks, and we look at the inputs and outputs and characteristics of these tasks. And if you make a code change that impacts some of these, it will invalidate these inputs and outputs, right, and invalidate the cache. Who is using the local build cache? It's not enabled by default, but who has this enabled for their projects? Who knows? Not too many folks. This is good. Well, bad for you, good for me. You learn something new and to try it out. So there's a local build cache and there's a remote build cache. So you have this thing called an incremental build cache. This is the up-to-dates that you see when you run a Gradle build, right? Now, your incremental build cache, if you change branches or projects, will be invalidated. It will be empty. So that's why you have this local build cache, so you could change branches and projects and still continue to have faster builds. Now you got this remote shared cache as well, right? So this thing sits on a server, CI seeds this remote shared cache. So as we get into this world of CI is just cranking and cranking away, it's populating this remote shared cache and also pulling from it as well. So you have, if you're running CI builds in the cloud or these containerized CI builds, and you're not using the remote shared cache, if you have one thing to take away from this, go and try to set this thing up, and I'll talk about that in a second. What's also interesting for this remote shared cache is when the developer comes in and run that first assemble, debug, or whatever build of the day, and all your caches, your incremental cache, your local build cache is empty, guess what? CI has been cranking away overnight. You can hit this remote shared cache, and it'll populate your local cache. So your first build could actually get substantially faster, and every continuous build will get faster because it's populating the local cache. Other cool stuff you can do, right? You're going to have stuff in your build that is not cacheable right out of the box. You have custom tasks, right? I was working with a customer, a large internet provider. I'm not going to name names. We saw like they had a lot of React Native stuff happening in their build from the UI team, right? These NPM tasks that are happening in there. Well, guess what? This stuff is not changing all the time. Let's not rerun it. And they were rerunning it every CI build, and it was 2 minutes. So we looked at changing the inputs and outputs of this custom task to make it cacheable. One of the cool things about Gradle Build Tool, which gives you that flexibility to automate more, right? And you can go to this kind of QR code and learn more about how you can do that to take advantage of some of the stuff that's happening in your build that's not cacheable right out of the box. All right, who's using the remote shared cache? Anybody here using the remote shared cache? We got a few. Okay, all right. And so it's really easy to set up, right? There's a free way via a Docker image. You scan this thing, and it'll take you to that link. It also ships with Gradle Enterprise, right? You can do a free trial of Gradle Enterprise, and you want to use build scans for analysis. And I'm going to do a kind of, not really a demo, but share some of what's happening. This is the Android X Jetpack Compose. Is Armis here? Armis? Okay, anybody from Jetpack Android X here? No, okay. Anyways, they use Gradle Enterprise, and you can go to this, check out their Gradle Enterprise instance and look around and see how they're doing and how their build times are and how many failures they have, all this good stuff. And so build caching, I remember when you sent me that first build scan, I looked at build cache was turned off. And you can come to this. This is a build scan, and you see you have switches here. You come there and you see, hey, how am I running the build? Do you have the daemon on? Is parallel enabled? All this fun stuff that speed up your build that Gradle provides, you don't have to take a training for it. And all those little links here, these will take you to the docs on, hey, how do I set up the configuration cache, for example, right? And in this case, I remember when we looked at your build, local cache wasn't even turned on. Right, and that was like one of the low-hanging fruits that we could find. So you can quickly go to switches in your build scan and see, hey, how am I using the build? How am I running the build? What can I do to make it faster or whatnot? One of my favorite tabs, if you want to see what's going on with the build performance, is obviously a performance tab there. You click on that and you have all these other options. I like to look at the build cache tab. That's where I would go first, right? What's your cacheability rate? In this case, right, local cache got 88% hits. So you get some information of how well is my build cache doing. What I then like to do is click on this task execution tab, right? And this really explains, hey, what stuff is my build running, right? And you can see tasks avoided from the cache, 730 tasks, but there was around 84 tasks that were not cacheable, right? We saw back here that cache hit rate was pretty good. It was 88%, cache hit. Some people would say, hey, this is great, right? Not a problem. Well, guess what? That remaining, 84 tasks is 12 minutes worth of stuff. And you can click on this button that says cacheable, and it'll show you, hey, what's all this stuff that's running that should have came from the cache but did not, right? And it sorts them by longest. And I like clicking on that little graphic to see the timeline view of what's happening and what's running in parallel. And then you can click on this critical path there to say, hey, I want to have an hour to spend on build times this week. Where should I look to gain the most time back for my developers, right? And in this case is this one task that's running, what is it called? Something, generate API task, right? And it's taking around 1 minute and 30 seconds, right? This is the lowest hanging fruit here. But the hard part is we don't know if this task ran because the code that was written before invalidated the cache, or is there some funny stuff happening underneath the hood? And for that, we have this thing called task input file capturing, where build scans will give you additional information on where is the stuff, what is happening, and where are the files that these things live in. Now, you still got to do some other things, but Gradle Enterprise gives you a nice build comparison feature where you can compare the last build with this one and find out exactly what is changing that is invalidating the cache, so you can find these timestamps that we showed earlier, which are really hard to find. So we did all this stuff. We found a whole bunch of bottlenecks in the build, right? We found there was a bunch of cache misses due to empty directories. Gradle Doctor plugin, fixed that. We saw some issues with AGP core tasks that were causing cache misses. Gradle Cache Fix plugin solved that. My colleague Nelson, he should be in here. Nelson, you here? There he is. He did a great job with building that. And then there was stuff with PNG files. Tell us a little bit more about what that was and how we found that.
Yes, so in our build, we were using some vector durable, and everything was generated as a PNG by Gradle for compatibility when the device don't support rendering of a vector. But the thing is, every time the PNG was generated, it was breaking the cache. And we realized, like, few months ago, we moved to API 21, Android API 21, which support rendering of SVG. So what we just did, we just removed the PNG generation, and that fixed. So the build on this task went from 3 minutes to 30 seconds, which is a good win. And
pretty big win.
And the last one is this generate build config is exactly the example I was showing you at first, where we have this build field populated from the Gradle to the build, and this was fixed by integrating a new Eng build mode in. Yeah.
And then the results came in. You're looking at the Gradle Enterprise instance, the performance dashboard here. Build times came down substantially on CI, around 46%. Average CI build time before all this was around 14 minutes, and then it came down to 8 minutes. The remote cache itself, it helps so much for CI, saving them around 6.6 minutes per CI build, right? And the best case, of course, was 3 minutes. The impact on PR builds was even more remarkable, right? Average PR check build time was like 39 minutes, came down to 25 minutes. And the best case down by 11 minutes. And then, we started high-fiving each other, right? Our job is done. We get to chill out, and 1 year later, we're like, hey, we should do this DroidCon talk and tell about these great successes that we had. And he's like, hold up. Let's make sure the build is in a good state. Was it in a good state? Cache misses are back. Different JDK versions, in major differences in JDK versions causing cache misses, setting up Android properties. Somebody was using an older version of Dagger that didn't have incremental compilation enabled. We thought we fixed this, but I guess it comes back, right? Code gen stuff happening, and why don't you talk a little bit about some of those?
Yes, so this is an example of the build, and this is an experiment when you want to run a CI build that is going to populate your remote cache, and you want to run a local build without the local cache, and with a clean build, so you want to measure the efficiency of the remote cache hit. And in that case, it was this experimentation where we have 800 tasks that get executed, even if we're supposed to have the same code than what was run on CI. So for that, what you want to do is in Gradle Enterprise, we have this task input comparison, and this is really a useful tool. So from this tool, you select your two builds, so your CI build on the left and local build on the right, and you just look at all the input difference for all the cacheable tasks. And this is an example where we see this JDK image difference on a Java compile, and so it's not giving you a lot of information from there, but what you can do is you can see there is two directories here. So one is on the CI, one is on your local machine, so you can just download these directories and use your favorite tool to make a comparison between those two. And you realize that, so it's definitely the JDK, but there is one minor difference in the manifest. And just two fields from the manifest differ. And the reason is we are running CI on Linux and we are running local on a MacBook, so there will be potentially always a difference. So once we find this difference, we can address the issue. And if you look at Gradle documentation, you can see you can use this normalization. And we are going to basically normalize the cache key by ignoring these two attributes. And this fixed our build, and we went back to 24 tasks executed, which was it's what we expect.
And it was really hard to find. I mean, how do you know what's sitting, where this manifest file, where it's sitting, where to find it, right? And it's a hard thing to do. And we wanted to kind of give the tools to the folks to find this stuff and make it easier, because not all of our jobs 24/7 is watching build times. And then, of course, everything was fine again, right? And PR builds got even faster. I mean, I showed a few slides ago, PR build time was 11 minutes, and now PR build times came down to 5 minutes. I mean, this is pretty huge, but we won't take full credit for it. So pop quiz, I got a Gradle shirt over here. I got to pull it out of my backpack. Does anybody know what changed in AGP 7.1 that contributed to such a substantial speed up in PR builds? Anybody? Boom! I owe you, exactly. And I even forgot where it was, thanks to the Android SDK team, Xavier's team, who manages AGP. I had to ping him, hey, which version was that? And we looked it up, 7.1. So anyways, we high-five each other again, right? Everything is all good, right? Myself, Nelson, and the Gradle team, we head to Paris for our company offsite. You know, we're drinking some wine, you know, hanging out in the rave cave, and then bam, my Slack is blowing up. It's Emmanuel, what's going on? Well, guess what? Cache misses are back again. A few days later, right? And what happened?
I needed to take some screenshot for the presentation, so I do the same experiment, and I expect to see 24 tasks, but I see 500 tasks. Okay, so something is wrong. So same investigation, you use a diff for the task input, and then we realize that we have a difference on the unexpected task, which is we have this Kotlin file, schema.kt, which seems to be different. And this is coming from Apollo Kotlin, which is our GraphQL client, which is generating all these classes from the GraphQL schema. So same principle. When we realized that the code generated on CI was not identical to the code generated on local, and the reason was that some of the models were added in the list in the different order, not the same order. So the code was quite the same, but so we just opened a pull request to Apollo Kotlin, and we fixed that. And it was merged pretty quickly, and then we were back to 20. 20 tasks executed.
Yeah, moral of the story is, folks, your build, as your code base increases, and sometimes it's just within a week, right? Developers are going to do certain things that are going to slow down your builds, and you need the right tools to watch this stuff, because the difference of the build time is substantial. And you saw these folks, 30 developers running 1,000 assemble debug builds a week, right? You talk about a couple of minutes here, even 1 minute, that's 1,000 engineering minutes wasted for 30 developers. So now this stuff is hard. We totally get it. Nelson and team built this awesome scripts, build validation scripts that you can run, and we'll find these bottlenecks that are happening in your build. And that's where a lot of our focus on developer productivity is, like, hey, how can we make stuff easier for you guys to run these scripts and find bottlenecks in your build and how to fix them? Now, dependency management, that's another big.
Okay, so yes, I wanted to talk about the dependencies. We got few issues in our build, and so the first one is like a lot of apps, we use dependencies.kt to declare all our dependency and to centralize everything. But the problem with that is everything in a build SRC is part of your build script. So this is going to break incremental compilation. So, and we have some library we update on a weekly basis, some internal libraries. So every time we do that, we are going to require all the developers and all the CI to rebuild everything. So what we looked recently is a Gradle version catalog, and it's a new feature in AGP, not in AGP, but in Gradle 7.4 before it was experimental, so now it's released. And it allows you to centralize all your dependencies in one or multiple file, but it's not going to break an incremental compilation. And this is great for us. And this is an example quickly. So the first snippet of code is how do you declare a dependency in this TOML file. So you put name and you put a group artifact. Everyone recognizes that. And the second snippet is how do you use the version catalog. So basically you have this keyword libs, and from libs you can access any library from your version catalog. And the great thing about that is you can use bundle. So take an example of all the Android X libraries. You don't want to list all your Android X library in this Gradle file, so you can just bundle them all together, and you bring all of Android X, and it's the same for Compose. So the QR code is going to the Gradle documentation about the version catalog. And this is an example of, I took the same code, two branch. One is using dependencies.kt for dependency. The other is using the version catalog. And it's a bit extreme, but it's just one dependency used by one module in our project. And you realize, like, if you still use the dependencies.kt and you rebuild after updating the version of this library, we have like 25 minutes of build time and 1,700 tasks executed. Versus if you're on Gradle catalog, we just recompile the modules that use the library. So this was a big win for us. The other thing I wanted to talk about is a problem we got in the past with dependencies is transitive dependencies. We have a lot of dependencies in our apps, and at one point, when we updated the fragment library, a couple of years ago, we realized after shipping everything to production that we broke the RTL rendering. And the reason was because AppCompat was updated at the same time, and we didn't test enough, and AppCompat was breaking RTL. So for that, we wanted a tool to have more control about what we ship, what dependency we ship. And at Netflix, there is this Netflix debugging plugin that has been developed, and they have a feature called dependency locking. And the idea is that you lock all your dependencies, including all the transitive dependencies and all the dynamic dependencies. And if the dependencies are not up to date because you use a snapshot or something like that, the build is going to fail. But we don't use that to fail the build. We just want to use that to track the change of our dependencies. This is an example of a version catalog, and we are bumping constant layout to 2.1.3, okay? And so this is the version catalog. This is the dependencies change we see in our app. And it's not just constant layout that get bumped to the next version, but we also see that solver get removed and core get added. So this log files allow us to really control what we ship to customers. And in a pull request, if you make a change to a dependency, we are going to publish this small table with all the impact you are doing on the build. So if you want to check this out, the QR code is linking to the documentation on Gradle, because this was in Nebula plugin from Netflix, but now it's in Gradle. And just a snippet of code, this is how you configure the dependency. So it's pretty simple. It's in the configuration, and you just activate dependency locking. And then when you run your task, Gradle app dependencies, you just add the option write logs, and this is going to write all these files. And usually you want to push this file to your Git repository to keep track of them.
And we do have this nice build speed challenge, right? We have a Gradle booth downstairs. You can kind of scan this thing and do a build speed challenge and try to speed up your build and send it to us, and you get some free stuff. You get a shirt, you get some socks. You know, it's a fun way to get you all to start playing around with caching a little bit, since half of you aren't really using it. And you can send me a build scan, right? There's this Gradle community Slack. Anybody can join. Right, you can find me in there at Rooz. Send me a build scan. I'll be happy to look at it. I mean, that's how we met. You know, maybe we can be friends too. If you want to try out Gradle Enterprise, there's a 30-day free trial, right? You can you install this thing on-prem. We'll help you set it up. You can check out the remote shared cache and use build scans and a lot of the stuff that we used here today to profile the Netflix build, and we can help you do the same. All right, just in case if you're going to forget everything that we said. Quick recap, right? You want to upgrade to the latest. Use BuildScans and Gradle Profiler. BuildScan, they're free. You don't have to buy anything to use those, right? At least use those. Make sure you're using the essentials. You got the daemon, you got parallel enabled. We were working with this very large bank, and they had, you know, these massive machines with many cores and workers and all this stuff. But somebody set max workers to 1, so they thought all this stuff is running in parallel, but it wasn't. So you want build scans to check those and whatnot. And of course, modularize. It's not just about build performance, right? You want to optimize your incremental build cache. Use those validation scripts that all the slides, we'll put it online. We're going to tweet it. DroidCon will tweet it as well. So if you didn't catch some of those QR codes, you can certainly do afterwards. And file washing, configuration cache, final boss, remote shared cache, right? If you're working on a large app, right, I would say large app, 8 or more Android developers on it is as complex as a 50-person Java app. Right? Use this remote shared cache, right? You can set it up in any ways. You got to build a cache backend, but it's really going to help your CI builds and your local builds as well. Cache Fix plugin, Gradle Doctor plugin, lots of cool stuff in there to use. By the way, Gradle is hiring. You know, we're hiring all sorts of folks, Android developers, Java developers, front end, back end, everything. And Android is hiring as well.
Yeah, the Android team is hiring too, so feel free.
That's it. Thanks, folks.